Simplifying algebraic fractions. Let's start with some numerical examples. So, for instance, simplifying 4/10. We know this simplifies to 2/5, but if we think about why, it's because 4 and 10 can both be divided by 2. 4 can be divided by 2 to make 2, 10 can be divided by 2 to make 5, so the answer is 4/5. Another way to think about this is to think that 4 is the same as 2 multiplied by 2, and 10 is the same as 2 multiplied by 5. We can then see that the 2's cancel from the numerator and the denominator, leaving us with 2/5 as an answer. Let's try this with another example. 12/30, 12/30. Now 12 can be divided by 6 to give us 2. 30 can also be divided by 6 to give us 5, so again the answer is 2/5. If we try breaking the fraction down into its factors again, 12 is the same as 2 multiplied by 2 multiplied by 3, and 30 is the same as 2 multiplied by 3 multiplied by 5. You can now see that a 2 would cancel from here and here, a 3 would cancel from here and here, leaving us with 2/5, another way of thinking about this particular fraction. If we now think about a particular example, 5/7 versus 6/10. 5/7 does not simplify, 6/10 does simplify. We can think of 6/10 as 2 multiplied by 3 over 2 multiplied by 5. 5/7, however, is 2 plus 3 over 2 plus 5. In this example here, 6/10, the 2 and the 2 cancel, leaving us with 3/5 as an answer. Whereas in this example here, for 5/7, although 5 is 2 plus 3 and 7 is 2 plus 5, these 2's here will not cancel and the answer is not the same as 3/5. So in order to have this cancellation, we need to see multiplication, and that's when common factors can cancel out. Let's now start to think about some algebraic examples. So for instance, starting very simply, 2x over 8. We can think of the fact that 2x is 2 multiplied by x, 8 is 2 multiplied by 4, so our 2 and our 2 cancel, leaving us with x over 4. Another way of thinking about this question is to think about the fact that 2x and 8 both divide by 2, so if we divide 2x by 2, we're left with x. If we divide 8 by 2, we're left with 4. So the answer is x over 4. Let's build this up and have a look at another example. 5xy over 10x. Now this time, think about common factors. There's a common factor of 5 in the numerator and the denominator. They both divide by 5, and they both divide by x as well. So essentially they both divide by 5x. Now, if we're working through this quickly, we could say 5x, if we just write out the question a little bit larger, we could say that the numerator, if we divide through by 5x, we're simply left with a y. In the denominator, if we divide that by 5x, we're left with a 2, so the answer is y over 2. Another way to think about this is to think 5 times x times y is being divided by 5 times 2 times x. Look at the cancellation, it's all multiplicative. Cancel, 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 cancel. We're left with y over 2. Again, the same answer. There are 2 further examples below. Try these and see whether you can work through to get the correct answers. 6a squared over 3a. Either write it out, 2 multiplied by 3 multiplied by a, all over 3a, and then cancel out 3a, 3a. Now when it appears that everything's cancelled out, it's because you've divided by 3a, and 3a divided by 3a is 1, so we're left with 1 in the denominator, so the answer is 2a over 1, which is exactly the same as 2a. Anything divided by 1 is self. The other way to think about this, 6a squared over 3a, is to think about dividing both the numerator and the denominator by common factors. 6 and 3 both have a common factor of 3. 6 divides by 3 to make 2, 3 divides by 3 to make 1. Now think about the a parts. A squared divides by a to make a divides by 1 to make 1. So in the numerator we're left with 2 times a, and the denominator with 1 times 1. So again, the answer is 2a. In the final example in this section, 3pq divided by pq, both the numerator and the denominator can be divided by p, and the numerator and denominator can both be divided by q as well, leaving us with 3 over 1, or simply 3. Let's look at some harder examples. We have here, first of all, 2q over 4q minus 10. Each three parts of this fraction have the same common factor. They are all divisible by 2. That's the highest common factor of each part of this. So, one way of doing this is to simply divide each visible term by 2. So, starting with 2q, 2q divided by 2 is q. Next, moving on to 4q, 4q divided by 2 is equal to 2q. And lastly, we've got negative 10 divided by 2, which gives us with an answer of negative 5. So the answer is q over 2q minus 5. Now, another way to think about this is to factorise the denominator. So we have 2q over 2 outside the bracket 2q minus 5. We can now see a common factor of 2 and 2 cancelling, numerator and denominator, leaving us with q over 2q minus 5. Similar example for the second question, 3p plus 15 over 12. All three parts of this can be divided by 3. So 3p divided by 3 is p, 15 divided by 3 is 5, and the denominator, 12 divided by 3 is 4. So the answer is p plus 5 over 4. Alternatively, again, using the concept of factorising, if we factorise the numerator, we've got 3 bracket p plus 5 over 12, and we can see a common factor of 3 will cancel in the numerator to leave us with a factor of 4 in the denominator, so p plus 5 over 4 is our answer. This factorisation technique can be very, very useful in examples like the next one. We have 4p squared plus 8p over 6p squared plus 12p. If we factorise out the numerator, we can take a common factor of 4p outside of a bracket, leaving us with p plus 2 inside the bracket. The denominator can be factorised, taking out a 6p, leaving us with p plus 2, again in the denominator. Now, what we can then see is there's a lot of potential to cancel this. We can cancel out a p and a p here. We can cancel out the whole of p plus 2 and p plus 2, and 4 and 6 both have a common factor of 2. 4 divided by 4 is 2, 6 divided by 2 is 3, so the answer is 2/3. Have a go at this next question. Factorise the numerator and the denominator, and then look for the cancellation of any common factors. In the numerator, let's take out a factor of 2x, x minus 3 in brackets. Denominator, again we can take out a factor of 2x, and inside the bracket we've got 2x plus 5 this time. Now we have a common factor of 2x, cancelling with a common factor of 2x, leaving us with x minus 3 over 2x plus 5. Now this is as far as this can be simplified. Do not be tempted to try and cross out the x's or cancel anything out. This cannot be simplified further. Remember that simplification relies on there being multiplication. Remember that when you simplify something like 6/10, It's because you have 2 multiplied by 3 over 2 multiplied by 5, and it's the multiplicative nature of these 2's that mean you are left with the 3/5. Now, let's have a look at some of the following examples. Before we do that, let's turn our attention again to the fact that 5/7 does not simplify, whereas 6/10 does simplify. So when we have 2 plus 3 over 2 plus 5, that does not cancel down any further. This is no longer a simple 2 on its own, or here, it is now a 2 plus 3, i.e. a 5, and this is now a 2 plus 5, i.e. a 7. So, if we have x plus 5 over x minus 2, this does not simplify. We cannot cancel down the x's, cross them out, anything like that, and it's really crucial that we understand that this does not simplify. However, this example is a bit different. If I have x plus 3 over 5x plus 15, notice if I factorise the denominator, 5 bracket x plus 3, I now have a factor of x plus 3 which will cancel with a whole factor of x plus 3, leaving me with 1 in the numerator, 1/5. So here I can simplify. I can divide through by the whole of the x plus 3 factors. If we try and apply this to these examples, factorise the numerator here, take out the 2, we have an x minus 4. Factorise the denominator, take out the 3, we have an x minus 4. We can now cancel the x minus 4 factors, leaving us with 2/3. Same with this second example here. If we factorise the 2 out of the denominator, we're left with 1 in the numerator because x plus 1 cancels from both the numerator and the denominator, leaving us with an answer of 1/2. Now, how do we simplify fractions that look like this? There's a quadratic expression in the numerator and a quadratic expression in the denominator. There's a terrible tendency where people try and cross out the x squareds, cross out the x's, try and cancel down the 9 and the 6. Unfortunately, that is very, very, very wrong. You need to factorise first. So if we factorise the numerator, we have x plus 3, x plus 3, and if we factorise the denominator, we have x plus 3, x plus 2. Remember, we need to find two numbers that multiply together to give us this number here, and add together to give us this number here. We can then cancel out a common factor of x plus 3, leaving us with x plus 3 in the numerator, x plus 2 in the denominator as our final answer. And do not be tempted to try and simplify that further. This is it. You cannot cross out these x's here. It just does not work. This is the final answer. If we try the second example, if we factorise out the numerator, take out the x, and we have x plus 4. Factorise the denominator, x plus 7 and x plus 2. Now what we notice here is that we have no common factors, neither in the numerator or the denominator, so this is the final answer. This does not simplify any further. This next example involves a difference of two squares in the numerator, so we can factorise this as x plus 4 x minus 4, and in the denominator we have x minus 4, x plus 1. These two numbers here, negative 4 and 1, multiply together to give us negative 4, add together to give us positive 3. We can then cancel x minus 4 and x minus 4, leaving us with x plus 4 over x plus 1. Our last example looks like this. 2x squared plus x minus 3 over 3x squared minus 7x plus 4. This involves factorising slightly harder quadratics, which is what we need to do first. So we're going to start by factorising 2x squared plus x minus 3. Start by multiplying this number here by this number here. So 2 multiplied by negative 3 equals negative 6. We then need to find two numbers that multiply together to give us this negative 6 and which add together to give us the 1 from here. There's only one pair of numbers that will do this, and it is negative 2 and 3. We can use this to split the middle term. So if we take 2x squared plus x minus 3, leave the 2x squared as it is, leave the negative 3 as it is, this middle term of plus x we can rewrite as negative 2x plus 3x using the negative 2 and the 3 from here. We then factorise the first part of this by taking out the 2x, brackets x minus 1. We know this factor of x minus 1 will be repeated over here, but we need a plus 3x and a minus 3, so we need a plus 3 here. When we then factorise out our x minus 1, we're left with x minus 1 and 2x plus 3. So this is the factorisation of the numerator. Some people prefer to do this using the grid method. So for instance, from this stage here, some people prefer to draw out a grid, a little multiplication grid. The top left-hand corner of the grid has the 2x squared term in it. This part has the negative 3. And then using the negative 2 and the 3 from here, we write negative 2x and positive 3x. We could do the negative 2x and the positive 3x in either of the two empty boxes. It doesn't matter which order we do that in. We then look at this first column and we notice that the two terms here have an x as their highest common factor. So if we take that out, we can write that here. We then know that in this box here we have to have a 2x because 2x multiplied by x gives us 2x squared. Then in this box over here we need to have a negative 1 because 2x multiplied by negative 1 is negative 2x, and finally here we need to make sure, and finally in this box over here we need to make sure we have a positive 3. We can then take this factor as x minus 1 and this factor here as 2x plus 3 and put them together to get our overall factorisation of 2x plus 3 and x minus 1. Try doing the same technique for the denominator and factorising this. So our denominator is 3x squared minus 7x plus 4. Try factorising this. You should find that the answer to the factorisation is this. 3x here, x here, 1 here, 4 here, negative, negative. So we can now write out the fraction (2x squared plus x minus 3) over 3x squared minus 7x plus 4 in its factorised form, 2x plus 3x minus 1 over 3x minus 4x minus 1. We can then cancel these common factors here, leaving us with our final answer of 2x plus 3 over 3x minus 4. And again, do not be tempted to try and cross out the x's or cancel the 2 and the negative 4 or anything like that. This is the final answer.